Hi folks, it's Mr. Moodledge here with another video. This time we're looking at reviewing for module number 3. So just a reminder, module number 3 is all about the three forms of the quadratic relation. So just looking here at schedule, just one second. So yeah, the title for this is the three forms of quadratics. All right, so I have 5 examples that I want to go over with you, which I think are really, really good examples for you to practice and do more questions on, and just focusing on those kinds of questions to really get the idea of what's important, what are the key takeaways of this module right here. Okay, so starting with this one right here. So a question like this, and I'll write out the question here. Okay, so just to give you an idea, all right. So the question reads, so I just came up with a question here. Identify the characteristics of the following equations. Okay, and I give you a few equations, and then I say put an x, put like an x, if that characteristic. And by the way, I forgot to mention this. I wanted to make a shout out in this video to Mortada. So thank you, Mortada, for bringing up this idea of making a video. If you hadn't mentioned it, I wouldn't have. This wouldn't have come to fruition. So thank you, and I appreciate the feedback. So it's very good. So that's. I'm sure this is going to help many students. All right. So back to the question at hand. So put an x if that characteristic is not visible in that equation. Okay, so once I write out the equations and kind of, if it's not visible, once I write it out and put the formatting of the question, you'll see what I mean, right? So we kind of have a table. So I have equation, and then let me just make a table. So I have a few columns. I'm going to have the equation obviously here. I'm going to have 3 equations. So 1, 2, and then 3. Okay, and then I'm going to have another column here for direction. So direction meaning like opening up or down. And then I'll have another column for x-intercepts, or x-int with an s, because sometimes, as you know, we could have 0, we could have 1, or we could have 2. So that, and then we'd have y-intercept, because there's only going to be one y-intercept, so I can't make that plural. Axis, and then so the axis is symmetry, and then the vertex, right? Some equations will, like, I also need you to know for the different forms, so the 3 different types of quadratics, forms of quadratics, which equation gives, like, is conducive to giving like different features, right? So I need you to know that as well, right? So I'm going to give you 3 types of equations, 3 of the 3 forms, hence the title of this module, right? So here's one. I have y equals, sorry, I have y equals negative half, y equals negative half x minus 4, and then in brackets, I have x plus 2. So negative 1/2 times x minus 4 in brackets times x plus 2 in brackets. So that's one form. I have another one, which is like y equals 3x minus 1 squared minus 12. And then I have another one, which is like y equals x squared minus 2x minus 15. Right? So the important thing to note is that, well, these 3 equations are not, there are 3 forms of quadratics, but they're not necessarily the same quadratic, right? I'm not telling you in any way that these are all the same equation. That's what I mean. But what you need to know is, what form of quadratic is this? Well, this looks like, okay, I have a number, and then this looks like 2 bracketed things, like 2 binomial. So this is what I call factored form. Okay, this is like my factored form. Because factored form, just to remind yourself, right? Factored form looks like, and I'll just write the note here. So factored form always looks like y equals a, like a number a, and then x minus r, x minus s, where r and s are like my zeros, and then a is that factor. Okay, so that's what factored form is. So we know that this is factored form because it looks like that, right? Here I could see the a is -1, and then I could see the r value is 4, and the s value is -2. I know this is a +2, but the s value, or the the actual 0, is going to be -2 because that's what makes this bracket 0. What makes this term, this thing 0, is 4, and that's what I'm talking about here, right? Because x minus 4 is what I have here. Okay. All right. So this is the factored form. This form right here is called vertex form because it looks like this. So vertex form, how it looks like generally is y equals a x minus h squared plus k. All right. So that's what generally it looks like. And literally, you can see here, a is 3, h is 1, and then k is -12. Okay, so that's vertex form, and then it's called vertex form because hk is my vertex, right? So here my vertex would be like 1 and -12. So you have to take whatever this number is right here and change the sign of that because it's -h, right? That gives you the x value of the vertex. All right, and last but not least, this form right here is called standard form because it looks like this. Standard form looks like y equals ax squared plus bx plus c, and really, like a, b, and c are numbers, so constants. So it's here, it's a is 1, b is -2, and c is -15, and it looks like that. So that's why it's called standard form. Okay, and we'll talk about what valuable thing I can get out of this. Well, I can get the a value, the b, and the c, but really the c is what is like I can get out of this by looking at it, is that's my y-intercept. Okay, because when x is 0, if that's what when y, like the y-axis is when x is 0. So if I want to see when it cuts the y-axis, then I just plug in x0, so these disappear and I end up with -15. So that's why it's my y-intercept. All right, now back to the question here. I'm looking at each one, the direction of opening. So direction of opening, right? Of opening. So I'm asking, like, literally it's asking, is it up or down? So really the easy way to do this is you're looking at the a value of each, right? This is an invisible one, and you're really just saying if it's negative, it's always going to open down like that. So down, right? These are parabolas. If it's a positive value, it's going to open up always. So that's up. If this is this is a +1 in front here, so it's going to open up. This U shape is just meant to show you, like, it's opening up. It's like the curve that's opening up, the U shape, and that's opening down. Okay, that's all. It's just up, down, like down, up, based on the a value. If it's negative, it's always going to be down. If it's positive, it's always going to be up. Okay, the x-intercepts, I'm looking, let's see at, when I think x-intercepts, the easiest one to think of is factored form right here, because literally these are my, they give me my x-intercepts immediately. So I'm looking at when does each bracket equal 0? Well, this first one equals 0 at x equals 4. So I have x equals 4 is one x-intercept, and the other x-intercept is when this second bracket equals 0, which is -2. So those are my two x-intercepts. If I want to look at the second equation here, now this is interesting because generally just by looking at this, I can't tell what the x-intercepts are. So I would just put an x here. That's what I mean here. From vertex form, it doesn't give me much. It doesn't give me anything about the x-intercepts. Only factored form does. So I put an x there. From standard form, I can't tell what the x-intercepts are. So I put an x there. Okay, so now moving on to the y-intercepts. The y-intercept, because there's only one for each equation, for each quadratic. Looking at this, I cannot tell what the y-intercept is. There's nothing here that tells me about the y-intercept, so put an x there. This does not tell me anything about the y-intercept, so I put an x there. This, however, does, because when x is 0, that's the y-intercept. That's when it crosses the y-axis. When x is 0, these things cancel, and I get a -15. So my y-intercept here is a -15. So I can get that confidently. For the axis of symmetry, I think that's how we spell symmetry. But for the axis of symmetry, it's funny because from the original, from this one right here, just by looking at this, I can't tell what the axis of symmetry is. Well, that's kind of I should actually know. I should be a little bit more careful about that. That's not actually true. Because even though I can't look at it, well, I do know that if I know one of my zeros and I know the other one, I know that my axis of symmetry is going to be right in the middle of those two. So really, I can actually tell my axis of symmetry. I'm going to go x is equal to 4 plus, I'm going to take the average of those two. So 4 plus -2 and then divide that by 2. So that's going to be like 4 minus 2 divided by 2 is just going to be 1. So my axis symmetry is x equals 1. Okay. Next, when I look at vertex form right here, the coordinate of h, so the x-axis of my vertex is my axis of symmetry. So it's just x equals 1. Okay, so that's my axis of symmetry. It's this, like, it's the value that makes this 0, which is 1. But the reason for that is because that's the, this is h and k, and the h value is my vertex, and the vertex goes through the axis symmetry, so x equals 1. All right, and last but not least, standard form right here. I cannot say anything about the axis symmetry just by looking at that, so I leave that there. Okay, so generally we're trying to limit the math just by looking at it, so I can't do anything. These, by the way, are like x, right? X equals, whereas this is like, I don't know, so I put an x there. Okay. Next, we go to vertex. I cannot tell the vertex from factored form. I cannot tell the vertex from standard form, but from vertex form, hence it's called vertex form, I can tell that it's just 1, -12. Okay, so that's it. 1, -12. All right, good. So we have, so that's pretty much, the basics of like the 3 forms. I hope you got a lot out of that one. But let's keep going. Okay. So clearly we could, that's that first preliminary question goes through a lot, unpacks a lot. So practice some of those and identifying the key features, right? Really, at the end of the day, I need you to know that in factored form, we get the zeros. That's the best, the most important thing that we can get, our x-intercepts. Right, and using those, I can get my axis symmetry. So knowing where these come from visually. From vertex form, I can get the vertex. Okay, that's the most important thing. And then I know what the axis symmetry is. I also know, if it's opening up, I know if it's a minimum here, and then I know the minimum value. That's just going to be the y value of the vertex. If it's opening down, then I know the maximum value. So those are also key features there from vertex form. From standard form, really the only thing of value that I get is this y-intercept, as you can see, right? So I hope you can appreciate why we have these different forms and what we can get out of each. All right, let's move into another question here. So here's another one. Something that looks like this, okay? So given an equation, oops, sorry, didn't mean to go back there. Given an equation, I have something like determine the x-intercepts. So again, I put brackets here just because I don't know if it's 0, 1, or 2 x-intercepts, right? I can have no x-intercepts. Like literally the graph can cross it nowhere at like 0, right? That would be 0. These would be examples of 0 x-intercepts. It doesn't cross the x-axis. These are all valid parabolas. It could be 1 x-intercept if it just crosses exactly once. Oops. So if it crosses it exactly, it's hard to draw one where it like goes just once, but like just touches it once. Or it could be like the traditional standard twice, right? That's what we're common to see, but don't always think that it's only going to be twice, right? All right, so the question I'm asking is determine the x-intercepts for this equation, right? So the equation is y equals -3 x minus 2 x plus 4. So it's in probably the best format for finding the x-intercepts, which is factored form, right? Factored form screams x-intercepts, okay, or also known as zeros. So I kind of give a hint. I kind of gave a hint right there. X-intercepts means it crosses the y-axis, which means x is 0. So literally, or sorry, which means y is 0, right? I'm looking at my focus point is where does it cross this line right here? That's the x-axis. So x-axis just means that y is 0 because it's crossing the y-axis at 0 right here. So it's crossing there. Everywhere on this line is 0 for y. So literally I plug in for my y, I plug in 0. And then I try to solve for x. So -3, x minus 2, x plus 4. And this question is really easy when you realize it's just the zero property rule, the zero property law. So things that multiply have to be equal to 0. Well, -3 is never going to be equal to 0. It's literally this is equal to 0 or this is equal to 0. So then I could just say this first term is equal to 0. This one right here, sorry, the second term is equal to 0 when x is equal to, so literally it's like x minus 2 equals 0. Then x is equal to 2, right? I add 2 to both sides when x is equal to 2. That's one solution. I have another solution when x plus 4 is equal to 0. That happens when x is -4. So there's my second solution, right? In each case, like here, I added 2 to both sides. Here, I minused 4 from both sides, right, to get that. So I have two solutions here. Those are both my x-intercepts for my graph, okay? So that's that. Okay, really, if I wanted to, by the way, if I wanted to sketch something like this, which will come up in another question, now I know one x-intercept is at 2, so let's say that could be like x equals 2, and another one's at -4, so let's imagine that's -4, and then we know it's opening down because it's a negative value, so it would probably look something like this. Just a rough sketch right there. I don't know what the y-intercept is, but that's not my concern. I can find out later, but I know just as a sketch, the quadratic's going to look, the parabola is going to look like that. But really the question was not asking me to sketch, just find the x-intercept. Okay, good. Now let's move on to another type of question. So that question was like the zero property law, okay? So another type of question, a third one, which is really good to know, is something like this, solving, so taking a step further, solving an equation, again, using the zero property law, but something like this. So solve the following equation. Right, so similar to zero property law, it's going to be something like this. So 0 equal to 3x, and then I could have something like, okay, 2x plus 3 minus 18. Okay, so it's still a quadratic, but it's just now it's in factored form. This is probably not what you think of when you think factored form, but these are two factors, two terms that still multiply. So technically, sorry, I should reiterate, this is not in perfect quadratic factored form because that would have to look like this, right? X minus r, x minus s, and there's like different things here, but just for the sake of it, it's like when two things are being multiplied, they can only equal 0 when one thing's equal to 0 or the other thing is equal to 0. So I get two solutions. So when I'm solving this, I'm using the zero property rule. So literally for this to work, 3x has to equal 0. That happens, divide both sides by 3, divide this by 3, and I get, it's a big one, I get x is equal to 0. That's one solution right off the bat. And the other one is when this term right here, that entire thing is equal to 0. So I'll write 2x plus 3 minus 18 is equal to 0. That happens when, let me add 18 to both sides first. Okay, so I will get 2x plus 3 is equal to 18. It disappears from the left, moves to the right, right? And then I'm going to divide both sides by 2 now. Right, when you do a lot of practice with this, you're always going to see this pattern of this is how it works when you're isolating for x. And so I get on the left side, x plus 3 is equal to 9. because 18 divided by 2 is 9. And now I'm going to subtract 3 from both sides. And alas, I get my final answer, x is equal to 6. So I have my two solutions, my two zeros, my two x-intercepts, if you will. They are going to be x equals 0 and x equals 6. Okay, so that's my two solutions. Those are my two solutions. Okay, that's how we can solve a question like that. All right, let's get into another important type for understanding the three forms of quadratics, which is going from standard form to factored and vertex form using algebra tiles. Okay, I want to emphasize for this module right here, we're going to do it visually using algebra tiles. So it's good to know how we can do that. Okay, so number 4, another representative, very good question is, I'll write it out here. So write equivalent expressions in factored and vertex. So I need you to know how to do both vertex forms, and it's good because we get to see how both are done in this case. And then I'll say using algebra tiles as well. For this first one, it's like for this type of question, I'd like you to use algebra tiles. Then after, in the future, you don't have to, but for this module, we'll stick to using algebra tiles, okay? So again, write equivalent expressions in factored and vertex form using algebra tiles for this expression right here. So the one I give you is x squared. So this example one right here is x squared plus 2x minus 15. Okay, so given that expression right there, I want you to do factored form for that, rewrite that in factored form and vertex form using algebra tiles. And it's important to note that when well, I'll split this in two actually to make it easier so we can compare and see. So that's my question right here, expression. I'll go left and right because here I'll show you factored form. Okay, and here we'll do vertex form. And I'll make some notes here just to, help us along the way. Factored form, and by the way, this right here is standard form, right? I'll put that in brackets right here. Standard form. Okay, so the key thing to note is that when we go from standard form to factored form, I am factoring, right? I literally like that. Sorry, I should reword that. That's what factored form is. But it's like, think of having a square, right? Or a rectangle rather. My goal is to get a rectangle and I'm trying to find the dimensions of those rectangles. Those are my factors. This, let's say this length right here and this width, I'm trying to figure out length and width. And my standard form is my answer, my area right here. Okay, so imagine that I had x squared plus 2x tiles minus 15. That's the area. I'm trying to figure out what length and width would that area have. Okay, so I'm trying to figure out W and L in factored form. Vertex form, the technique is called completing the square. Completing the square. And it means that I'm trying to use these side lengths to complete a square. And then this, so it's going to be a perfect square and then plus minus some tiles here as an additional, right? And this is going to be a binomial and this is going to be a binomial and it's going to be a perfect square. So yeah, that's what completing the square is. Okay, so we'll do this, but that's just an overview. Okay, so if I were to now go ahead with this, I would let's just start with factored form. So some key things to remember about algebra tiles. This right here, when I have a square, a big square, it's going to be an x squared. It's an x by an x. Okay, blue means positive, red means negative. So that's a positive, that's an x squared. If I had let's say the color red, I could draw negative x squared, and the reason how this works is one's negative x and the other is x. Okay, that's how I get an area of negative x squared. I can also have bars, which are like rectangles of area x. So this works for something that is x long and 1 wide. right? This unit right here is 1. 1 times x is x. Okay, I can have it in red as well. So red version of this would be negative x, and that would work for x long and negative 1 wide. And then last but not least, I have the squares here. So the unit tile, so this would be an area of 1. It's just a 1 by 1. And then I have a negative tile as well. This would be a negative 1. That would be like a negative 1 by a 1. Okay. All right. Good. So that's how I get an area of negative 1, right? Good. Now I know that like how to use my tiles. Let's go with factored form here first. So the trick for factored form is if you have an x squared, just put a, it's positive here. So just put a square at the top left corner, call that x squared, okay? Next, once you've dealt with the x squared, you're gonna move straight to the units. So I have negative 15, right? So I'm gonna draw negative 15, and this is what you have to ask yourself. What are my options for the negative 15? Right? So how many rectangles can I make that have an area of negative 15? Well, I can make a 5 by 3. I can make a 15 by 1, right? That would give me a 15 as well. I could, and then I think those are my only options. Yes, I could make a 5 by 3 or 15 by 1. If you tried to do this by making like a 15 unit tiles like this, and it's just one long, you would quickly see that 2x tile like rectangles are not going to be enough to fill in all those spots. It's just going to be a disaster. It wouldn't work, which is why a better resort would be to use a 5 by 3. So let's try this and you'll see why this works. So I'm going to have 5 negative tiles. So 1, 2, 3, 4, 5, and then 3 rows of that, right? So by 3. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Just like that. And these are all negative tiles, right? Negative unit tiles. And now you could see that there are 15 of them because 5 times 3 is 15, and it's negative because one of the sides is negative. Okay, so I have now a negative 15. Now I can go ahead and fill in the positive 2x, but you just got to be careful here, right? So it looks like when I'm filling these in, I want to fill them out like this. So I have my I have my 2x's here, like this. So 1, 2. And you just have to be very careful when you're doing this because you want to have all whatever side you're doing, you want to have all positives. If you're doing this thing, it has to all be it has to be one sign, okay? You can't have a mix of positives and like negatives, right? Stuff like that. Like that would not work. That's breaking the rules. It has to all be one sign here and one sign here for it to be factorable. Then I can actually determine the dimension, right? So the reason I made that an x and an x is I literally have 2 x's. Okay, I have all this empty space here and here. What am I going to do? How am I going to use the bars? This is where I could use that the rule of 0 pairs. I'm going to introduce 3 positive rectangles here. So that's positive, positive, positive. I just introduced 3 positives out of nowhere because I didn't have 3 positive x's, but now I do. So that means that I have to introduce 3 negative x's here. Negative x, negative x, and negative x. And look at that. It fills my rectangle. I have a nice, I've factored this essentially. I've made it into a rectangle. Now, and that works because these 3 negatives cancel with these positive x's, and these 3 negative x's cancel. So I'm left with my original tiles, right? So I can use 0 pairs because one of these cancels with one of these, and so on. Okay, good. So that's good. Now I just measuring the dimensions. So this is an x, right? Remember the x squared is an x by x. The width of an x rectangle is just 1. Okay, and then these are all, remember this right here is a negative 1, negative 1, negative 1. It's a negative 1 by x. So altogether, this side right here is x minus 3 because I have 3 negatives. And this side right here is x plus 1, 2, 3, 4, 5. So my final answer, this expression in factored form, would just be x plus 5 and then x minus 3. That would be the answer to that in factored form. It comes from this side length times this side length gives me an area of this right there. Okay, so it checks out now. All right, so that is factored form. Let's see how to go from the same expression into vertex form. So look at the similarities and differences, right? I'm going to start with my x squared like square right at the top left corner. So make that a little bit more squarish. So like that. This has an area of x squared. And now for this situation, instead of jumping to the units and kind of splitting that, I want to look at the middle, the x terms first for completing the square, for turning it into vertex form. I take whatever I have here and split it into two. The idea here is you want to think it's a square, so it needs to be like somewhat symmetrical, right? That's the key property of squares. So then to make it symmetrical, I'm going to take an x, put it here, and the other x, I'm going to put it here. Notice they're both positive because it's a positive 2x. So that's going to be an x and an x. Okay, that's all. And now you're just going to notice what thing goes here, right? If I wanted to complete the square, it's like I'd literally have to add a positive 1 tile, right? I'd have to add a positive tile. So let me just make that positive, a unit tile. And because I just added a positive tile out of nowhere, I have to take away a positive tile because otherwise that doesn't, I can't just introduce something and not make it equal to what I already have, right? So I had to take that away as well. But don't worry, I have a lot of other things which I did not add yet. I just have I just have 15, I'll just do it this way. I have 15 negative tiles. That's just equivalent to doing like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I just want to make it aware that I'm not making any shape here. I'm just noticing that all together here I have 15 negatives, right? So at the end of the day, now I've completed my square, believe it or not. Look at these dimensions. So this is going to be an x by an x, and this is going to be a 1 by a 1. So I can clearly see that this right here is just x plus 1 times x plus 1, which is just x plus 1 squared. And then I have this leftover right here, which is that negative, and then 15 more. So it's actually going to be negative 16, actually. Sorry, it's a typo. So it's going to be negative 16 altogether. So I would have this, x plus 1 all squared minus 16. And this would be my answer in vertex form. There's one thing I just want you to look here in when you're going, like when you're completing the square, this unit right here, how many spaces there are, that bottom right, for completing the square is always going to have to be a positive. Because even if I had a negative x here and a negative x here, negative 1 times negative 1 is a positive 1. Same thing with a positive 1 times positive 1. So it's always going to be the same. So it's always going to be positive, right? All right, and that's how I do that. Look at that. I started with this standard form expression, and then I converted it into factored form and vertex form. All right, we're almost at the end. So there's lots of math there. And notice I just sketched it using algebra tiles. Okay, so one final question right here, just to put everything into context. This one actually is more of applying it to real life kind of situation, so a real world problem. And here I'm specifically looking at vertex form, because that generally, it's real world problems are usually in that format, and it's nicer to interpret them. But here's a final question. So number 5, this is a real world one. Real world, more like a application type question, and it's dealing with vertex form. So this is the question, right? Put this in brackets. Okay, so the question is the monthly, right? These are good questions for you to practice as well. The monthly profit earned by a food truck is given by, and then I give you the equation here. So let's say the profit is given by P equals negative x minus 5 squared plus 40. Okay, so I have to define some of these variables here, the p and the x. So let me write that here, where x is the number, I'll just do short form, right? X is the number of catering events, booked. And P, so that's what X is, and P is the profit. P is, so I'll underline that. P is the profit in thousands, let's say, in thousands. So P is like, whatever number you get, you got to multiply that by 1,000 to get the actual in dollar amounts. Okay, so I'll just highlight that as well, underline that as well. Okay. All right, first question. First sub question here. So now I know everything, right, about this thing. It's like profit is modeled by this equation, and what form is it in? Well, it's vertex form, so just knowing that, okay? All right, so first part of question here is sketch this relationship, or this equation right here. It's just asking me to sketch that one. And then let's also label any characteristics visible in, label any characteristic visible in the equation. So in the equation, for on the graph, label it. Okay, so let's go through that first. So I have my my x and y. It's a sketch, so I don't need to really include units that much. I'm just drawing the shape. This is in vertex form, so I know the vertex is 15 and 40. So 15, let's say, is here. 40 would be like over here. So the vertex would be like here. And clearly it's opening down because that's a negative. I don't know where the zeros are going to be. That's not my concern right now. I'm just going to do something like this. Sure, something like that. And that's my sketch. That's all I want to kind of include. I will notice here that the vertex, I'll write that down. It's going to be 15, 40. Okay, so 15, when I have 15 catering events, the profit is going to be $40,000. $40,000. Okay, so it's like it's a maximum profit I get when I have 15 catering events. Okay, so even there, I'm like answering some questions for the future, but that's what the sketch looks like. Okay, all right, it's an upside U going through where the vertex is at 1540, based on this information here. Okay, part B. So there's a few parts to this question, but part B is, what is the maximum profit? So what is the max profit? Okay, so question mark there. What I want you to realize here is, like we said, it's in vertex form. So the maximum of this graph literally, and it told me what is the max profit, but then it's clear that it's opening down, but they didn't have to tell me that, this question. So anyways, it's just redundant, but I could see the max here. So the Y value, it's 40. So I would say, what is the max profit? Well, it's 40,000. 40,000, or just like I can write that like this here, 40 and then 3 zeros, dollars. Okay, $40,000, that's it. And it occurs when when I have 15 catering events. Okay, all right. Two more parts here. Another part that's very often asked is, how many events must be booked to earn the max profit? Okay, that's a very good question. It's like, if I wanted to earn the max profit, how much events would I have to book? Well, literally, it's the x value of my vertex, right? It's like, it's asking me, how do I get 40? Well, I get 40 when I'm at 15 in x, right? It's like 15 in x, and then that gives me to 40. That's how I get that point. What does that mean? Well, it means that I have, well, axis symmetry is 15, but really it's the x coordinate of my vertex. So right here. So when I have 15, how many events must be booked? 15 must be booked to earn the max profit. All right. And then last but not least, a typical question is using something involving substitution now, which is, or evaluating, which is something like, what is the profit? So P, or loss, oops, didn't mean to paste that, or loss if, so I'd say like, we don't know if it's profit or loss, it could be negative as well. What is the profit or loss if 8 events are booked? Right, so that's what that is talking about right there. So if 8 events are booked, what is the profit or loss? Well, it literally gives me the x value, right? And I have my equation right here. So just plug into x that value, and then you'll get the profit, right? So P, let me write it here. P is equal to negative x minus 15 squared plus 40. Yes, right there. And so now I know my x. So my x is equal to 8. So I'm going to replace x with 8 here. And I'm going to put bracket minus 15 bracket squared plus 40 negative. And so let's simplify this. Let's keep going. I need to do brackets first inside. So negative 8 minus 15 is negative 7 squared plus 40. A lot of you might, accidentally, think negative, that's going to be a positive. And then that's true, but I can't multiply first because there's an exponent. I have to do this first. So negative 7 times negative 7 is going to be positive 49. And then plus 40. And now you could multiply that negative and positive to get negative 49 plus 40. And now for the final answer, you would see that the profit would equal, that would be negative 9. So therefore, this is shorthand for writing therefore. It's like the little 3 dotted triangle. It's just, in conclusion, there would be a loss. There would be a loss of $9,000. Because it's in thousands of dollars, it would be negative $9,000 if the food truck sells, or if the food truck goes with just 8 catering events. So it would be a loss, right? So we could probably see that like at 8, it's probably like somewhere over there in the negatives. Negative 9,000. Yeah. Okay. So that is a summary of everything you need to know for module number 3. Please go ahead and practice from your, practice questions, or likewise practice some questions related to this. So real world, using algebra tiles, solving quadratics, and when it's like using the zero property, finding the x-intercepts, realizing that you could use a zero property here if it's in factored form given to you like this. And then noticing about the different features of the 3 forms of quadratics, right? So that's the conclusion there. Good luck, and let me know if you have any questions. Thank you.